So here's some word problems with logistic equations. I'm sorry I didn't print these off ahead of time so that you could have them in your notes. But if you need to write them, then that's fine. At least you can pause it and do that. So there's this high school, and it has 1,300 students. There are 4 honors society officers and 21 other members. They spread a rumor on day 0 that Mr. Schwartz is to become principal. A day later, 62 students know the rumor. What happens over 10 days? When is the rumor spreading the fastest? So first of all, it doesn't tell you it's logistic. Most of the time it would say write a logistic equation, but I'm telling you when it's talking about rumors, it's logistic. One of the reasons you know when an equation is logistic is when you're trying to do something and you can't get more than an amount. For example, when this rumor is spread, more than 1,300 students at this high school can't know the rumor because there's only 1,300 students at the high school. So that's kind of the tricky part here. Alright, so first of all, you're going to write the equation. We don't know K. Basically, you're just filling in everything. The only thing we know is that the L is 1,300 because there's 1,300 people at the high school, so that's as much as it can be. Alright, so that's the first part of it. The other things that we know that on day 0, that 25 people total start the rumor because of the 4 members of the Honor Society and the 21 other members. So on day 0, 25 people have the rumor. We also know that on day 1, 62 people know the rumor. Alright, that information is going to help us to figure out A. See, after you write this equation, then you can go ahead and say, okay, I know that P is 1,300 over A, well, we've been writing the 1 plus first, 1 plus A e to the negative KT. I can figure out A because it is the limit minus what I know on the day 1 or day 0 divided by day 0. And so I get 51 for A. So we have P equals 1,300 over 1 plus 51 e to the negative KT. Alright, so now I can solve for K. And that's what the 162 is for. We're going to plug the 62 in for P. And then the T is 1, so that's just a negative K. Cross multiply. Divide by 62. And you'll divide by 62 and then you'll subtract 1. So I'm just going to go skip a step just because of the sake of room here. So 1,300 divided by 62 and then subtracted 1, you get 19.967. Just keep that whole decimal in the calculator. Divide by 51. Take natural log on both sides and then divide by the negative, so K is 0.9377. Again, just make sure that you keep that whole decimal in the calculator. Alright, so the question's asking me 2 things. What happens over 10 days? Well, now that I know all of the information, then I can just plug a 10. Okay, hang on. That is supposed to be negative 0.9377t. And if I want to know what's happening after 10 days, then I can just plug a 10 in for the t, and you would get that 1,294 people know the rumor. The other question is, when is the rumor spreading the fastest? That is like what we've done before. So here's the equation, and when I find out when the rumor is spreading the fastest, I know that it spreads the fastest when half of the people know the rumor. So I set it equal to 650 because half of 1300 is 650. So if it just said how many people know it when it's the fastest, it's 650, but that will tell us the time when it's spreading the fastest. And so this is just solving the way we did yesterday. So you're going to cross multiply. And then you'll divide by 650. Subtract 1, divide by 51, take the natural log on both sides, divide by negative 0.9377. I'm going to go ahead and tell you that it's 4.193. And that means on the 4th day is when this particular rumor is spreading the fastest. Alright, one more example. Kind of the same problem, it's still talking about the same rumor. They said that they weren't content with this rumor, so they start the next rumor. That's telling you that it starts off with only 4 people knowing it. And he's going to start the rumor that they'll be president of the school board, just those 4 people. It travels with the same transmission coefficient. That means that K is still the same value, which is the negative 0.9377. Normally you'd have to find that K. What happens over the 10 days? When's the rumor spreading the fastest? So the difference is when we set up this equation, the A changes. I already know the K. But because it starts off at 0.4, that means that A is 1300 minus 4 over 4, and you get 324. So when we have our equation, our A is a different value. To figure out what's happening at the 10th day, you just plug in the 10. So when T equals 10, you get 1265, which doesn't change much. And then to find out when it's spreading the fastest, then you're going to set this equation equal to 650 again, because when half of the people know the rumor is when it spreads the fastest. If you solve that, I'm just going to tell you get 6.164 days. And that makes sense that it should be less days because it starts off with less people knowing the rumor. Alright, here's your try problem, and it's just one word problem, but I'm going to get you started with it a little bit. We're talking about panthers. We're not talking about rumors. This is the Florida Panthers. A conservation organization releases 25 Florida panthers into a game preserve. After 2 years, there are 39 panthers in the preserve. The Florida Preserve has a carrying capacity of 200. This right here tells you that that is the L. The releasing the 25 tells you that at 0 it's 25, and after 2 years it's 39, so it's 239. So that gives you lots of information. Write a logistic equation. So you start off with dp dt equals, think about, we don't know anything. We can find A, but it's Kp times 1 minus P over the L, which is the capacity, which is the 200. And then from there, I think you can get the A using the 0.25. Find the population after 5 years, so you'll plug in the 5 for T after you find K. When will the population reach 100? You'll set that equal to 100 and solve. And then E, at what time is the panther population growing most rapidly? Well, it'll be growing most rapidly when P is 100, so you'll set that thing equal to 100, and you'll realize that you have already found that in C.